the Medical Center, and my job was to recruit the faculty and to help the faculty put together the academic programs that I'm going to be talking with you about today. UC Merced is a research university. What does that mean to you as students? Any ideas? What does a research university mean to you? You get to participate in research, yes? Even for undergraduates, very unusual compared to other UCs, which are much bigger. What else does it mean to you? Scholarships? B. What else?
Hands-on learning.
Pardon?
Hands-on learning.
Hands-on learning, certainly in some classes, hands-on learning. What about your faculty? What would distinguish your faculty here at UC Merced from faculty that are not at a research university?
Because your faculty are doing research in a field they're that much farther ahead of
Who said that? There you go. That's a very key difference between faculty at a research university and those at universities that are not research. They are the ones that are making the advances in their field. And faculty that are recruited here at UC Merced are UC quality faculty in all sense of the word. They are excellent teachers, but they are also recruited because they have excellent research programs. If they're senior faculty, they have established research programs. If they're young faculty starting out, they view it as a potential for having developing stellar programs. We are continuing to recruit and expand our faculty. This year we've recruited, we have 5 new faculty, and I'll tell you how the competition for some of these positions are. Some of the positions we have 200 faculty, 200 applicants applying for one position. So being a faculty member at UC is very prestigious, and while UC Merced is young, the faculty here are equally prestigious as at other UC campuses. So I'm going to run through a presentation for you. We could take questions throughout if there are not too many, but there will be some time for questions afterwards. So much of this information you can get on your website, on the Natural Science website. How many of you have gone there? Okay. I really encourage you to go to the Natural Sciences website. It has much of the information that I'm going to be talking about with you today. It also lists the faculty and their research areas, what the disciplines are in which they're teaching, their undergraduate programs, and the graduate programs as well. So 5 undergraduate majors in the School of Natural Sciences, and all of these majors are based on a core plus emphasis model that I will be talking to you in a little bit more detail. The current majors are applied mathematics, biological sciences, chemical sciences, earth system sciences, and physics. So one of the things you'll see if you compare our programs to what you might find at other UCs is that we have 5 majors instead of 25 majors. And this is done on purpose because we want you as students to have the most flexibility to be able to start a program and change from that program if you so desire. Most of you will change your mind a couple times during your college career as to what you think you want to do or even what major you want to take. And with even between science majors, if you start out being a physics major and you decide you want to be a biology major, you have at least 2 years to make that decision, and you can make that switch without a lot of loss of time. And this is what the faculty are very interested in trying to give you the flexibility to make those choices, because you're coming out of high school, most of you, there may be some transfer students here, but you think you know what you want to do. At university or college, it's about exploring options, trying to figure out what do you want to do, what do you like, where are your strengths, and what feels good to you, because you are going to be here getting a preparation for your future careers. So what does the core plus emphasis model mean? It means that every undergraduate in the School of Natural Sciences spends the first couple of years taking introductory chemistry, introductory biology, calculus, and physics. And these are fundamental courses that you take regardless of your major. Each major then will build on the knowledge gained in these core courses to allow you to develop increasing breadth and depth in the discipline that you choose. So I'll just go quickly through some of the majors. Applied mathematical sciences. We have an applied math major here rather than simply a math major. And that reflects some very fundamental visioning at the very beginning of our recruiting of our faculty, that we wanted to have faculty who would teach math in an applied sense. And that means mathematics to solve real-world problems. And so all of our math faculty, in their research areas, they are applying math to solve problems in the real world, whether it be looking for developing new algorithms to find hidden objects in random media. What's a hidden object in a random media? You may not know what that is, but many of you would know what it is if you would think about looking for a tumor, for example, on a CT scan. How do they find tumors, a hidden object, on a CT scan? Mathematicians are the ones that develop those algorithms to do that. And so our mathematics program is focuses on applied math, and you'll get the foundations of mathematics and the skills to apply mathematics to real-world problems. In your third and fourth year, you can decide, well, I'm interested in math, I want to be a math major, but I want to have an emphasis in computations, or computational biology, or economics, or engineering mechanics, or you can design your own emphasis together with the math faculty. And what the emphasis means for all the majors is that in your upper division courses, you're going to take a series of courses that are going to relate your fundamentals in that major to these different emphasis areas. So you don't have to decide what you want to do if you're a math major right when you're a freshman. And you can have the flexibility to decide that later on. I just pulled out a couple of sample plans from the website. And again, please go back and look at this. This is a sample plan for math with an emphasis on computational biology. And what is shown in yellow are the required courses for all of the students in the natural sciences major. And what's shown in light blue, if you can see it, are the general education requirements to satisfy the UC Merced general education and also the general ed requirements for the school. And you can see in the general education that we encourage you to take classes outside your major almost every semester. This is important so that you're not just focused on science or math, but that you do develop a broader understanding of the world in which we live. The courses in yellow are those that are required fundamental core courses, and so someone who's a math major who's interested in computational biology would be taking the courses that are listed here in semesters 1 through 8. And you can see that in semester 5, 6, 7, 8, the courses that the individual would take would have more of a biology or computational biology emphasis, but it would be in the context of mathematics applied to that. Where does a math major lead? Many, many places. It can lead you to careers in telecommunications. It can lead you to careers in banking, in entertainment, animation, special effects. Math majors are very much involved in that. Research and development, nanotech, imaging, computing, teaching. You teach in college, teach in high school, teach in elementary school. And of course, research, grad programs at UC Merced, or grad programs throughout the nation and the world. And there's a lot one can do with a math major because you're developing these fundamental skills in quantitative reasoning and critical analysis. Applied math research at UC Merced takes many different flavors. For example, Francois Bobcat studies fluid dynamics. Mike Sprague studies fluid-solid interactions, fluid flowing through porous media, such as you might find in different layers of the earth, solar, electronics, and circuits. A couple of our professors, just to highlight, Harish Bhatt is in research interest in linear and nonlinear waves, and he's very interested in short wavelength phenomena of spatially discrete systems. These words mean not too much to you at this point, but they will mean more to you later. And I mentioned Francois Bobcat. He's interested in fluid dynamics, how different types of particles settle in the surrounding fluid. Lots of applications to environmental systems. Biological sciences major. Biology is the largest major on this campus. 35%, well now 37% of all the students on this campus are biology majors. Biology is a very exciting area right now. The biology that we have here for an undergrad program is different than it is on other campuses.